No questions? If anyone has any question, please let me know. Am I audible?
Yes, sir.
Okay, so if you don't have, did you guys solve tutorials? I have uploaded 4 tutorials till now.
Sir, when did you upload the fourth one?
After last lecture.
Okay.
Okay, I have also uploaded all the slides till last week. Today I will upload the acid one also. Okay, any questions? No question? Okay, so if there is no question, then I will go ahead. I will explain a bit again acid base catalysis, and then I will go and start discussing tutorials. Okay, so in the last lecture, I discussed about mechanism, and I'm just only going to repeat it again. Uh, this is your acid, BH plus, and S is your substrate. That gives you B base plus SH plus. SH plus is intermediate. When SH plus reacts with W, this species, it gives S plus WH plus. Okay, so this is the general mechanism. Uh, in the last lecture, I discussed about that W can be water, but W can also be base, and we will see this. If it is base, then what happens? Okay, so this is the general mechanism, which basically includes both general acid catalyzed or a specific acid catalyzed reaction. Okay, so let's start with W. When W is water, then what will happen that BH plus S gives you B plus SH plus, then SH plus water gives you product plus H3O plus. Okay, so suppose this is K1, this is K minus 1, this is K2, then what the V will be K2, K1, BH plus naught. Okay, so this is initial concentration, substrate concentration into H2O, because these are the 3 reactants, and then K minus 1 B naught plus K1 S naught B, since B is formed here. So K minus 1 B naught plus K1 K1 this S naught, because now we are expressing in terms of initial concentration. So we'll take K1 S naught if S naught is quite greater than BH plus naught. Remember, S naught is in excess. Okay. In that case, there will be a S naught term in the denominator, A plus K2 into H2O, because this is K2 into H2O. Okay. So even just by, since we have done so much practice that we know that for this, what will be the rate of reaction. Now, suppose BH plus naught is quite greater than S naught, then what will happen? There will be term BH plus naught in place of K1 S naught. So K1, K2, then BH plus naught, and S naught, S2O, K minus 1 B naught plus K1 BH plus naught plus K2 S2O. This K2 into H2O will be a constant, K2 into K1 into H2O will be another constant. So that way you can also write this thing. But here we have assumed that this is K1, K minus 1, this is K2. In that, if you keep those things in mind, then you will get something like this. Okay. Then think about this. If S naught is a small, in that case, we can neglect this. And then, you know, okay, we can neglect this. So this is first order with respect to rate will be first order with respect to S naught. Okay. When K1 S naught is quite greater, we can neglect these two terms, and then it is zero order with respect to S naught. So that's what it is showing. So V versus S naught will be like this. And in this case, when you have taken excess amount of acid, in that case, certainly we are comparing with the substrate concentration. In that case, initially it will be first order, and again same way that if you neglect this, then the order is your rate of reaction is first order with respect to BH plus naught. And if BH plus naught is quite high, in that case, these two terms can be neglected, and then BH plus naught cancels out, and then this is zero order with respect to BH plus naught. Is this okay?
So when BH plus not, like last time also you told, so when BH plus not or S not when it's low, like in when case, let's see in the first case when S not is really high compared to BH plus not, and then we are saying that when S not is low it will be first order. So how are we making that comparison? Like it is much bigger than BH plus not, but it's also small enough that it gets neglected in the
Yeah,
denominator.
that's true. That's true. So in that case, what I'm saying that S naught is quite greater than BH plus naught. So in that case, what will happen that we have this kind of thing, am I right? And in that case, certainly this K1 S naught will should be less than this K minus 1 B naught plus K2 S2O. Then only we can neglect this, am I right?
Yes, sir.
So we are talking about concentration uh, in the range, concentration of substrate in the range when K1 S naught is negligible in comparison to these two terms. Is this okay?
Yes.
Okay. So please keep this thing in mind. A bit confusing, but just think about that excess concentration we are comparing with BH plus naught. So please keep that thing in mind. S naught is comparing BH plus naught, but S naught itself can be smaller. Uh, Here we are comparing S naught concentration with itself, not with the BH plus naught. Okay. BH plus naught, it is always greater than S naught will be always quite greater than BH plus naught. Then only I can get this expression. Okay. And then similarly here, if we do BH plus naught, it's quite greater than S naught. So please keep this thing. Just one. Okay. Oh. Hello, can you listen me now?
Yes, sir.
Sorry. Yes. So there was problem with the charging. I forgot to start charging. Okay, so okay, so can you see slides?
Yes, sir.
Yes,
Okay.
sir.
So here I was saying that if substrate concentration is high, then there will be one term in the denominator which will have substrate term. And if acid is in high concentration, then we have an acid term. So please keep this thing in mind. Although there is a two steps only, we have three terms because now we are expressing rate of reaction in terms of initial concentration. That is the only difference which you need to keep in mind. Okay, so BH plus naught is greater than S naught, then we have this term K1, K is not BH plus naught. So now we have included the concentration of water in this K, and that's why I am writing K is not BH plus naught. K minus 1 B, because there is B formed in the one step prior to rate determining step, plus K1 BH plus naught, K1 BH plus naught, and this K1 BH plus naught, because this is in excess. That's what we have seen. I have written here, plus K2. Okay. If the second step is slow, so this is when there is three terms, am I right? So B is intermediate reacting with B, so there is a one term, and intermediate reacting with water, so there is another term. Am I right? This is because we are expressing the terms, uh, expressing the rate of reaction in terms of initial concentration. So this is the whole equation. If suppose K2 is small, in that case you will have K1 S naught BH plus naught. So this you neglect and then you divide by B. Right? Then in that case K is not BH plus naught by B. K minus 1 B by B, by B cancels out. K1 plus naught by B. Okay. Why I am doing that? Because we know that BH plus naught by B can be expressed in terms of H plus. And so when you express this in terms of H plus, BH plus by B is equal to H plus by K. K is acid dissociation constant. Right? Then your rate of reaction will be K into S naught H plus by K, K minus 1 plus K1 by H plus. So now you see rate of reaction can only can be expressed in terms of H plus ion concentration. H plus ion concentration. Okay, so that is very important point to remember, that K is not H plus by Ka, K minus 1 plus K1 H plus by Ka. So now rate of reaction depends only on H plus ion concentration. In other way you can say it depends on not BH plus not concentration, but BH plus not by B concentration, which is basically dependent on H plus ion concentration. And so this is a specific acid catalyzed reaction. So please keep that thing in mind, that if only when this second step is slow, then we have a specific acid catalyzed reaction. Is this clear?
So if second step is not slow, then we won't have H plus.
Then it will depend on BH plus not BH plus not concentration. Okay, it will not. Then in that case, it is the general acid catalyzed reaction. I will discuss that case in the next slide. But please keep in mind when it is a specific acid catalyzed reaction. Shilpa. Okay. So so please keep that thing in mind. All right. That only when second step is slow, then it is a specific acid catalyzed reaction. Let's see what will happen when second step is not slow. Okay. So this case we are going to see here. that K2 is quite greater than K minus 1B. Okay, this acid concentration is still quite high. So in the denominator term, there will be BH plus naught term. But when K2 is quite greater than K minus 1B, in that case, what will happen? This can be neglected. Okay, this can be neglected. This K2 can also be neglected. And then we have, K1 BH plus naught plus K2. K1 is fast. Certainly K1 is fast. So K1 into BH plus naught. In that case, you can also write K1 BH plus naught plus K2. It doesn't matter. But, when this K1 is generally very high, only thing is, between K minus 1 and K2, there is a comparison. So you can see rate of reaction is K BH plus naught into S naught. Particularly when BH plus naught is quite high, then it will be K1 BH plus naught. Otherwise, it is rate of reaction is simply K BH plus naught into S naught. So into K1 BH plus naught. K2 is quite greater than K2. So at the low concentration of BH plus naught, then you have like this cancels out. In that case, your rate of reaction is dependent on first order with respect to BH plus concentration. Okay, so keep this thing in mind. And now it is not dependent on BH plus by B concentration. And that's why this is a general acid case. General acid catalyzed reaction. So all depends on what is the value of rate constants. Okay, if K2 is quite less than this, then you have the case of a specific acid catalyzed reaction. If K2 is quite greater than this, then it is general acid catalyzed reaction. Okay. Now what we will do is we will go to this case. When W is B, when W is B, in that case, your rate is equal to will become constant multiplied by BH plus naught into S naught and then divided by certain things. What will be that is given here. Okay. So what you will get is, I think let us see here. So you will get this term SH plus. So here SH plus, if you apply a steady state reaction, what you will get is K minus 1 SH plus into B is equal to, so D SH plus okay, let me see what it has done. SH plus is equal to, okay, we can ourselves do it. It doesn't matter. Let me see. Okay, so let us see what we have written. BH plus S giving you B plus SH plus, and then same thing, SH plus B gives you product plus BH plus. Okay, so this is your whole reaction. K1, K minus 1, and this is K2. So let's write dSH plus by dt. dSH plus by dt is equal to, क्या करना शुरू कर देते हैं यार, उसको बोलो, K1 BH plus into S minus K minus 1 B into SH plus minus K2 SH plus into B. That's what probably we have written. So K minus 1 plus K2, because both involve same step, this is equal to 0. Am I right? So you can write K1 BH plus into S is equal to K minus 1 into B, K minus 1 plus, let's take K2. So this is common, into B into SH plus. And suppose BH plus in excess, then I will write this. Am I right? And then K1 BH plus naught. Just 1 minute. Please give me 1 minute. Okay. So this is your BH plus naught, K1 BH plus naught into S. S is, if I want to write in S naught term, then I will write simply S naught minus SH plus. Is equal to K minus 1 plus K2 B SH plus. Okay. Then SH plus term you can take that side. So K1 BH plus naught into S naught. And if you take this side, then this will be K1 K minus 1 plus K2 plus what? K1 BH plus 1 naught. Into SH plus. Is this okay? So SH plus is K1 BH plus naught S naught by K minus 1. Did I miss something? There should be B also. Am I right? This B.
Yes, sir.
So I think I missed this. So this is with the B. So K minus 1 B, K2 B. And plus K1 BH plus naught. So K1 B, and that is quite obvious. Am I right? K2 B plus K1 BH plus naught. Is this okay? Simple thing. K minus 1 is, B is here. K minus 1 into B, B is here. So K2 into B plus K1 into BH plus naught. Okay. So this is your SH plus, and similarly you can write for what is the rate of reaction. So let us see. Yeah, please.
Previous slide.
Yes.
Sir, you transformed K1, K2B in something.
क्या बोल रहे हो? Can you just again?
Sir, how you wrote S equals to S naught minus SH plus? Y minus SH plus?
Yeah, because S, okay, S you see, this is we are also again looking at the initial concentration. So what we are saying that S naught is S plus your SH plus. That's what we are taking. And so S can be written as S naught minus SH plus. Is this okay?
Sir, is this the concentration of S naught we are taking initially?
S
S naught.
naught is the initial concentration. Okay.
Okay, sir.
Initial concentration. Okay. And one thing you can say that S is also going to P. So we are talking about rate of reaction at a time when generally we take at a time when P is very small. Okay. So then we are talking, we can write simply S naught is equal to S plus SH plus. Generally it should be plus P also. Isn't it? So kinetics, you remember that in kinetics, we are not looking at the equilibrium concentration. Okay. So here, when P is negligible, then I can write S naught is equal to S plus SH plus. So S is equal to S naught minus SH plus. Is this okay?
Yes.
Okay. So because this is simply mass balance, you know, mass balance. You must have heard about mass balance, am I right? जो initial concentration होगा S का, that will either will go to SH plus or P. If it is P is negligible, in that case, I can simply write S naught is equal to S plus SH plus. Is this okay?
Yes, sir.
Okay. So, yeah, so you can simply write, okay. So let me write here probably. So what did we write? SH plus is equal to, if you remember, we did write BH plus naught, K1 BH plus naught, K1 BH plus naught, S naught divided by what we did right, K minus 1 plus K2
into
B and plus
K1
K1 BH plus naught.
no.
Is this okay?
Yes,
That's
sir.
what we expect from this. And so V will be what? K1 BH plus naught S naught into B K1 K2. Okay. B, because V is equal to K2 into SH plus into B. Am I right? V is equal to K2 into SH plus into B. Okay. So that's what I am trying to write. So K minus 1 plus K2 plus K1 BH plus naught. Okay. And then if I divide by B, what I will get? K1 K2 BH plus naught into S naught into B. Sorry, B will cancel out. What is left is K minus 1 plus K2 into B. B cancels out plus K1 BH plus naught by B. Now, tell me, in this case, what will happen? If suppose second step is slow.
specific acid.
नहीं कैसे होगा, मान लो K2 neglect कर रहे हैं, am I right? We cannot neglect K1, am I right?
Okay.
So what will happen? This will depend on H plus and this will depend on what? BH plus naught. So it is depending on both BH plus naught and B and H plus, sorry. BH plus naught and BH plus naught by B. When if suppose K minus 1 is negligible, still we have same case. Okay. So this in this case, you will not have any specific acid catalyzed reaction. It will be always general acid catalyzed reaction. Okay, in which your rate of reaction depends on both BH plus naught and H plus ion concentration. Is this okay?
Yes, sir. So why is it only in the case when reverse second reaction is negligible?
Why in case? What did you ask?
You told that this is only like this would only be general acid catalyzed if the second reaction is negligible.
नहीं, इसमें तो कुछ नहीं होगा.
नहीं होगा ना ऐसा कुछ. हाँ.
इसमें तो both cases, whether second step is slow or this reverse step is slow, in both cases it will be dependent on both BH plus ion concentration and H plus ion concentration. So in both cases you have general acid catalyzed reaction, not a specific acid catalyzed reaction. So please keep that thing in mind. Okay. Okay, so that's what it is. So this is all about. Similarly, you can think about base catalyzed reaction, but yeah. So now you understand in which case it can be acid catalyzed, in which case it can be base catalyzed. A lot of organic reaction are catalyzed by either H plus ion or BH plus ion, BH plus ion. So either it is acid catalyzed or specific acid catalyzed or general acid catalyzed reaction. And you understand now difference between specific acid catalyzed and general acid catalyzed reaction. Specific acid catalyzed means it only depends on H plus concentration. It means if suppose in one reaction formic acid is formic acid is catalyst, and in the second reaction suppose acetic acid is catalyzed. So even if I take same concentration of formic acid and acetic acid, the rate of reaction will be different. Okay, because that acid dissociation constant is different. Okay, acid means their acid dissociation constant is different, and so they are going to have different rate of reaction. Yes, if the pH which you have taken just by adding formic acid and acetic acid, if pH is same, not concentration, then you should expect rate of reaction to be same. Okay. In some cases, like in the last case, what we discussed, it depends on both. It depends on the concentration of both. It means that acid and concentration of H plus. In that case, in neither cases, formic acid or acetic acid rate is going to be same. Okay. when a reaction is only catalyzed by BH plus ion. In that case, if I take same concentration of acetic acid and formic acid, then rate of reaction is going to be same. Okay. So now I will stop and let's discuss about tutorial a bit.
So just 1 minute. So in specific acid catalyzed, it is necessary that the second reaction is slow step, right?
Yes, second reaction is slow step and water is involved.
What? Oh. So, but in this case, like, okay.
Not this. Please keep that thing in mind.
Yes,
In this case, I just showed you that it will means in any condition you can't have, you know, you can't have a condition in any condition you can't have a situation where rate of reaction only depends on H plus ion. Am I right?
Yes, either BH plus or other concentration would be required.
Both. It will depend on both BH plus concentration and BH plus by B concentration. Okay. So you see three different cases, and we have seen all these three different cases has been observed in organic reaction, which are acid catalyzed organic reactions.
So first case is like general acid, second is specific, and third one is only BH plus.
Yeah, that is also known as general, but in that you need to keep in mind that only depends on BH plus ion content. Okay.
So, but my question was like, when we are saying that in water is involved in its specific acid catalyzed, so second step is slow. That is a necessary condition so that K2 term gets.
You are right. Not only second step should be slow, your water should also be involved.
Okay.
It is okay.
Yes, sir.
Yeah. Any other questions? So okay, so I will stop here, and then let's discuss one by one. What I will do, I will upload your tutorials, and let's discuss whether you are able to solve. Or maybe I can give one question to you. Let us see how many of you can solve. So, okay, so let me find out. So this is fourth tutorial which I am going to discuss first, and then let us see. So C is 3 thrice Cl plus OH minus. I think this we have already discussed or not?
Discussed. We
Already discussed?
Yes, sir.
Okay. So
this is the one in which you have to use water also, right?
yes. So I have already discussed. So let us go do this. 2V3 plus 2 Hg2 plus gives you 2V4 plus Hg2 2 plus. Okay, and then rate of reaction by dt is equal to K V3 plus square Hg2 plus by K dash V4 plus V3 plus. Yeah, then tell one mechanism. Yes. Are you able to solve? Yes, any question? Am I audible?
Yes, sir.
Yes. Rohit?
Sir, is the intermediate Hg plus? What is intermediate is Hg plus?
Okay, I don't know. I have to see that. Okay. So how many steps? Anyone? Himanshi, how many steps you expect?
Two.
2. Yes. Okay. So
Sir?
first step. Yeah.
So-
So 2 steps. Am I right? So let's write like this. Okay. Now tell me here what I should write. Intermediate के अलावा क्या बनेगा यहाँ?
V plus 4.
V4 plus.
V4 plus. Okay. And here
V3 plus.
V3 plus. Good. And now I have to write intermediate. Am I right? Intermediate के लिए क्या करते हैं? पहले इसको मानना पड़ेगा slow. So if I take this as a slow step, then what I have to neglect? This term. Am I right? Because this will have K2 into something. And so this is neglected. So what is the transition state composition? What will be the intermediate composition? Reactant composition in the rate determining step. अब हमने मान लिया कि rate determining, तो इसका हम निकाल सकते हैं. So what should be the composition? Can you tell me?
1V, 1Hg, and charge should be 4.
1V, 1Hg, and charge should be
plus 4. Plus 4.
plus 4. Okay, so let us see. 1V cancels out 1Hg, 4 plus है तो 6, 6 plus 2, 8, minus 4, 4. So V3 plus already is there. So एक V चला गया और 3 plus से 1 plus बचा. So what will be here?
Hg plus 1.
Good. Hg plus. Hg plus. So what is here? ये क्या होगा? V 3 plus plus Hg
Hg plus.
Hg2 plus. That's all. Yeah, this should come from here, and then there should be charge and mass balance. And here, what we will get? Hg
2 plus.
Yeah, ये कैसे होगा? बनना क्या चाहिए यहाँ? V4 plus. You see, let me write this. V4 plus ही बनेगा ना एक. तो एक Hg बचा रह गया. Hg2 plus कैसे बनेगा? Is this okay? Now you see, in this step you can't make Hg2 plus. Remember that. Can we make it? एक ही Hg है. Right? So certainly Hg2 plus will not be formed. What will be formed? Then V4 plus. तो अगर V4 plus होगा, क्योंकि this is the product, then what is left is Hg. Now question is Hg2 plus कैसे बनेगा? This Hg is also an intermediate. So this Hg must react with one Hg plus to give you Hg2 plus. अब बताओ, अब इसको बैलेंस कैसे करोगे?
Sir, sir, in the last step, it shouldn't be Hg plus 2.
Hg plus 2 plus होना चाहिए. Okay. Hg2 2 plus था, right?
Sir, in the reactant side, Hg plus की जगह.
यहाँ पे कह रहे हो आप?
Yes, sir.
Let
Hg plus
me-
2.
Yeah, you are right. So this should be Hg2 plus because यहाँ पे 2 plus है. Am I right? Yes, you are right. Hg2 plus plus Hg gives you Hg2 2 plus. This is okay. Now it is balanced. You are right. It should be Hg2 plus, not Hg plus. Hg plus already used up हो गया. Again, it depends on what product you have. Product is Hg2 2 plus. एक Hg है तो और किसके साथ करेगा? Hg2 plus के साथ ही करेगा. And now if you balance, you have a 2 V3 plus, you have 2 Hg2 plus. This Hg cancels out, this Hg plus cancels out. And then you have this whole reaction. Right, so you need to keep this thing in mind. But once you know this, it is not that difficult to do because this Hg must be utilized. Right, so this Hg either should it should not react with intermediate because if it reacts with intermediate, there will be another term here. So basically, it should react with the reactant only. So Hg2 plus is the reactant and plus Hg is Hg2 2 plus. It gives you Hg2 2 plus. Is this okay?
Yes, sir. But
Yes,
one
sir.
question is this: is the all three reactions should give the final reaction?
Yes.
Because in when
हाँ तो final क्या होगा?
because sir, when the topic is ongoing, the one reaction is done in which it is not giving the final reaction.
Yes, that's why this step is needed.
Okay, sir.
Also, this is not a product, so please keep that thing in mind. ये total में आ जाएगा Hg, which is not here. So certainly this must be utilized. This
Okay.
is not the product of the reaction. You look at this. ये आया ही because we want to balance this thing. We want to have V4 plus, which already has been formed, and we want to have Hg2 2 plus, not Hg. Right? And that's why it has been done here. Hg2 plus plus Hg. That's why I told you that 2 steps we can write from this rate of reaction. After that, we utilize our own intuition. That certainly the final reaction should be this. And Hg is not the product. So it must be utilized. So एक तो और होगा ही, one step ज़्यादा होगा ही. There's no doubt about that. And I have already told that 2 terms doesn't mean that there will be only 2 steps. And I have shown this thing here. It only means that this step will not be slow. Sorry, it is means this is negligible. This contribution to rate law is negligible. Okay.
Yes, sir.
So please keep this thing in mind. This is how mechanism of reactions are written. So I have shown you some complex reactions. And just by logic, you can add other steps. And this also tells you that if there are 2 steps in denominator, it doesn't mean that there should be 2 steps. It only says that there should be at least 2 steps. Okay. It can be more than 2 steps. And generally, the more than 2 steps you do, keeping in mind that your final reactions should have this composition. Okay.
Yes, sir, got it.
Okay, so next class, again tomorrow class, I will discuss tutorials only. Okay, please solve it, and because it is very difficult to discuss all the questions in the tutorial, but I will focus on those questions which you are not able to do. Okay, is this okay?
Yes.
Okay.
Yes.
Thank you, sir.
Welcome.